7.2 Scale Diagrams and Reductions. So in the last video we talked about the scale diagrams and enlargements, so making it bigger, and we noticed that the scale factor was always greater than 1. So you're multiplying the side by 2 or 4 or 1.00000001, even if it's the slightest enlargement, but they're always going to be bigger than 1. However, let's talk about when we take something in real life and we take something and then we scale it down. Maybe we need to do that so that it fits better in a promotional item, a promotional poster, say, that we're making, but somehow we need to make that image smaller. So a scale diagram can be smaller than the original diagram. This type of scale diagram is called a reduction. So here's a life-size button, and here's a scale diagram. It's like, here in the original diagram here, it's like what I've done is I've taken this, taken the whole thing and created it smaller. So like, see how what I'm doing right now, how I'm creating it smaller and larger? Those are kind of like the scale diagrams. So it's like the same proportions. The proportions are exactly the same. It's just a little bit smaller. So since each side is a reduction, the scale factor will be less than 1. So just like in the enlargements, there are 3 different types of questions that I can ask you about scale diagrams. So determine the scale factor. I'm just going to zoom into this a little bit more. So if I'm determining the scale factor is always, just as in the other one, is the scale length. So the scale diagram length over the original length. Determine the size of the original. Well, what you need to do there is you need to say the original is going to be your scale length. Okay, I'm using these mean this exact same thing. The scale length and the scale diagram length is the exact same. So the scale diagram length divided by the scale factor. And last but not least, determine the size of the reduction. So I'm going to take the original, multiply it by your scale factor, and you're going to get your scale length. Talk about example 1. Draw a scale diagram of this octagon. Now let's pause here for a second. Let's see how many sides this is. 1, 2, 3, 4, 5, 6, 7, 8. So this is kind of a weird looking octagon, because in our minds, my guess is that we see kind of a shape that looks like this. More like that. This is a regular octagon. I mean, mine didn't turn out very regular, because you can see that some of the internal angles are smaller or larger than others. But you're kind of thinking about a shape probably that looks more like that. Well, this is a shape with 8 sides, so it's an octagon. It's not a regular octagon, but it still is an octagon. So what we're supposed to do here is we're supposed to draw a scale diagram of it, and we need to use a scale factor of 0.25. Well, first things first, let's measure. So remember, each of the more significant ticks is 1. So I have 1, 2, 3, 4, 5, 6. So this side is going to be 6 centimeters, and same with this, 6 centimeters. This right here is going to be 1, 2, 3, 4. So that means that this is 4 centimeters and this is 4 centimeters. Let's measure this side right here. My gut says that it's 6, but let's check it out. 1, 2, 3, 4, 5, 6. Yep. So this is going to be 6. Oh. 6 centimeters. And let's see what the other ones are. This one is 1 times 2 centimeters. And this one is also 2. And this one is also 2 centimeters, 2 centimeters. So first things first, we need to multiply the original by the scale factor. So for 6 centimeters, we're going to multiply that by 0.25, and we're going to get 1.5 centimeters. We're going to take 4 centimeters, multiply it by 0.25, and we're going to get 1 centimeter. And we're going to say 2 centimeters multiply 0.25 is going to be 0.5 centimeter. Okay, so let's draw this here. So instead of having 6 centimeters, I'm going to have 1.5 centimeters. So I have 1.5. I'm going to change this here. It has to be exactly at 0. I'm going to go here and draw another 1.5. And then down here, another 1.5. Now I'm going to remove this perpendicular. It has to be exactly 90. So let's wait for it. Yeah, oh, close. There we go. So we're going to be going down 0.5 centimeter. Because we're going down 2 centimeters here. And we will be going up 0.5 centimeter. Now we're going to be going in here 1 centimeter. Oh, that's going to be, I'm going to go exactly right there. Okay, so here we are. I'm just down here, make this same line. And last but not least, I want to get this up to 90 again, and do that last 0.5 centimeter. Now, if you were to be using a real ruler instead of a digital ruler, I think that will be a lot easier for you. The main thing is make sure that you guys know how to calculate the size of the reduction. Look at that, so teeny tiny. And it wasn't quite precise because truly this and this should be the same, but I think you get the picture. Example number 2. Here is a scale diagram of a top view of the truck. Okay, so the scale is 1 to 50. So first things first, the length of the truck is 4 meters. So we're saying from here to here, it's going to be 4 meters. The front and back wheels are 3 points. So here's a wheel, and here's a wheel, and here's a wheel, and here's a wheel. So what they're saying is that the wheels are 3.85 meters apart. So how far should the wheels be on the scale diagram? So what we are looking for is we are given original, and we need to get to scale diagram. So if we're given the original and we want to get the length of the scale diagram, we say original times the scale factor. That's going to equal the scale length. So first things first, the only difficult thing about this is that the original, we know what that is. So we can say that that is 3.85. But the scale factor, 1 to 50, another way that we can say that is 1 over 50. Oh, not 15. 1 over 50. So that's going to be our scale length. So I'm going to get my calculator here, and I'm going to say, okay, so 3.85 times, I can say 1 divided by 50, or I can just divide the whole thing by 50, and it's going to be 0.077. So it's going to be 0.077 meters is the scale length. If we want to get really fancy and maybe say, maybe what we'll do is we'll say that we want this in centimeters, we would just multiply this by 100. So 0.077 times 100 is, we just move the decimal place over, so that's 0.7, sorry, it's going to be 7.7 centimeters. So let's go to our summary. So in summary, scale diagrams that are smaller than the original are called reductions. Their scale factor will always be less than 1. So why don't you go right now and grab a worksheet, work through it, and then write your master check.